Determine the following information for the parabola given by the quadratic function f of x equals negative 3 times the square of x plus 1 plus 4, then graph the parabola. Notice the quadratic function is in vertex form, sometimes called standard form, which is the form y equals a times the square of x minus h plus k, where h comma k is the vertex, and x equals h is the axis of symmetry. In addition, if a is positive, the parabola opens up. If a is negative, the parabola opens down. Comparing vertex form to the given function, notice h is equal to negative 1 because x minus negative 1 simplifies to x plus 1, and k is positive 4, which indicates the vertex is negative 1 comma 4. Let's go ahead and plot this on the coordinate plane. Also notice because a is negative, we know the parabola opens down. The axis of symmetry is x equals h, which is the vertical line passing through the vertex. In our case, the equation of the axis of symmetry is x equals negative 1. Next, we're asked to determine the x-intercepts. We want the exact values. The x-intercepts are the points where the parabola intersects the x-axis. Every point on the x-axis has a y value or function value of 0, which indicates to determine the x-intercepts, we set f of x equal to 0 and solve for x. This gives us the equation 0 equals negative 3 times the square of x plus 1 plus 4. To begin, we need to isolate the square of x plus 1 by first subtracting 4 on both sides. Next, we divide both sides by negative 3. Simplifying, we have 4/3 equals the square of x plus 1. Next, we undo the squaring by square rooting both sides of the equation. But remember, when we square a positive or square a negative, the result is positive, which indicates we'll have two solutions. When we square root both sides of the equation, we need to include a plus or minus on the left to make sure we get both solutions. On the left, the square root of 4/3 equals the square root of 4 divided by the square root of 3, because the square root of 4 is 2. We can write the left side as plus or minus 2 divided by square root 3 equals on the right. The square root of the square of x plus 1 simplifies to x plus 1. And then to solve for x, we subtract 1 on both sides. We have x equals negative 1 plus or minus 2 divided by square root 3. We may be able to leave the x values or x-intercepts in this form. Let's also show how to rationalize the denominator of 2 divided by square root 3 and then find the sum and difference. We have x equals negative 1 plus or minus 2 divided by square root 3. To rationalize the denominator of 2 divided by square root 3, we multiply the numerator and denominator by the square root of 3. This gives us x equals negative 1 plus or minus 2 square root 3 divided by 3. And we know negative 1 equals negative 3/3. We have x equals negative 3/3 plus or minus 2 square root 3 divided by 3. Now that we have a common denominator, we can add and subtract. We have x equals the quantity negative 3 plus or minus 2 divided by square root 3, all divided by 3. Let's use the x values in this form to give the x-intercepts, which are points on the coordinate plane, and therefore need to be given as ordered pairs. The x-intercept on the left would be negative 3 minus 2 divided by square root 3 divided by 3 comma 0, and the x-intercept on the right would be negative 3 plus 2 divided by square root 3, all divided by 3 comma 0. Now to plot these on the coordinate plane, we'll want to get decimal approximations, which I've already done. The x-intercepts are approximately negative 2.15 and 0.15, which should be approximately here, and let's say here. Again, this x-intercept is negative 3 minus 2 square root 3, all divided by 3 comma 0, and this x-intercept is negative 3 plus 2 square root 3, all divided by 3 comma 0. Next, we want to determine the y-intercept, The y-intercept is where the parabola intersects the y-axis. Every point on the y-axis has an x value of 0, which indicates to find the y-intercept, we set x equal to 0 and solve for y, or determine f of 0. F of 0 is equal to negative 3 times the square of 0 plus 1 plus 4. Simplifying, we have negative 3 times the square of 1, which is just 1, plus 4. And negative 3 plus 4 is positive 1. The y-intercept is the point 0, 1. Let's also plot this on the coordinate plane. While we're here, let's also sketch the axis of symmetry, which again is a vertical line passing through the vertex with the equation of x equals negative 1. Before we determine the domain and range, notice the y-intercept is 1 unit to the right of the axis of symmetry, which indicates it's also a point 1 unit to the left of the axis of symmetry, which would be here, where the ordered pair is negative 2, 1. Let's go ahead and graph the parabola. The domain for any quadratic function is all reals. There are no restrictions on the inputs or x values. We express all reals using interval notation as the open interval from negative infinity to positive infinity. The range is a set of all possible outputs, and because the vertex is the point in negative 1, 4, and the parabola opens down, notice the y values or function values approach negative infinity, the range is the interval from negative infinity to the y value of the vertex, which is 4, and the range includes 4, and therefore we use a square bracket to the right of 4. I hope you found this helpful.